Welcome to a KNAUER Academy video tutorial on KNAUER HPLC columns and column selection, and especially on columns for the HPLC of small molecules. If you are already familiar with KNAUER HPLC columns, you might know that they can be separated into three major groups. And today we are talking about the silica gel based phases for the HPLC and UHPLC of small molecules. They can be separated to normal phase columns, helic columns, and also to reversed phase columns. And we will now have a look on what this means. So if we are talking about the silica gel based stationary phases, we have to take into account some parameters from these phases to compare them to each other or to know something about their selectivity. So first of all, you have the ground silica gel, and this already has the parameters like their metal content that defines the purity of the silica gel. You have the particle shape and the pore size and also the specific surface. And the specific surface is somehow linked to the pore size, because when the pore size gets smaller, of course the surface gets bigger, because you have more pores per particle and therewith more surface on it. But this is not everything. Most often you don't use a bare silica gel, but a modified one. So you also have to look at the modification of this silica gel. And this also has characteristics like the type of the phase. So what are you bringing on the phase, and also the style of the end capping, or if you have an end capping or not, especially in reversed phase mode. The pore size is also affected by the modification. You can imagine if you have the pore size from the bare silica gel and bring chemically something on the surface, of course, pores get smaller. So the chemistry is also really interesting. So what is the phase that you bring on? And in the end, for reversed phase, also the carbon content of the phase is really interesting when you compare columns. So overall, all these points lead to the selectivity of your stationary phase. And this is, you see, also the case why there are so many different columns on the market, because there are so many points affecting their selectivity. But let's have first a look about what is a reversed phase particle. So here you see a silica gel, bare silica gel, nothing on it. And if you want to make now a chemical reaction to get a reversed phase particle, you first have to bring on a chain. Here it's an example, most often used as C18 chain. So you do a chemical modification step and bring these chains on your silica gel particle. And the result now is a non-end capped C18 phase. If you want to have an end capping, you will need a second modification step. So the column producer now does a second reaction to bring some groups on the remaining places where there are no C18 chains on the silica gel surface. And these rest could be nearly anything. And this again leads to there are so many different selectivities on the market, also for C18 columns. But now if you look at the C18 column, how does the separation on this works? So if you compare reverse phase columns, you have to keep in mind that there is always a hydrophobic interaction. This means the interaction of your analyte with a hydrophobic C18 chain. Yeah, so it can also be a different chain, but here, for example, is the C18 chain. A second one is the hydrogen bonding capacity of your phase. So there is still some places on the silica gel where the silica gel itself reacts with your analyte. So this is where hydrogen bonding occurs, and this is also very important. And at this third parameter, the steric selectivity of your phase is important. If you have some C18 chains that don't let bigger molecules get in between, then it is a steric selectivity. If they can go in between, again, the small selectivity is there. But now let's have a look on different column modifications. So first of all, what we already saw here is a classical C18 phase with an end capping. So this is, for example, our Eurosphere 2 C18 modification. But then you can also have different C18 modifications. For example, a C18A, or sometimes it's called C18AQ phase. Here you do an end capping with a polar group. This is something really special because these phases can be used with pure water content, and this is something really nice because you can run C18 columns on pure water. C18H is something different again. So the H stands for hydrophobic, and here you bring highly hydrophobic end capping groups on your silica gel particle after the C18 modification. And also there are C18P phases on the market, for example our Eurosphere 2 C18P phase, and the P stands for a polymeric end capping. So you see here there is a normal end capping step, you have some groups marked with an R, and afterwards there's a polymeric bonding between the C18 chains. And this is also something really special that leads to a high stability of this phase also in different pH ranges. But what are now the typical analytes? For example, with a classical C18 phase that is really often used, you can use unpolar analytes up to a little bit more polar analytes, and for example something like penicillin is typically used for a C18 phase. The C18A, I told you, is more polar, and here you can use also polar analytes. If you want to analyze acetic acid, for example, you can never do it with a classical C18 phase. First point is acetic acid is so polar it won't be retained on a C18 phase because the C18 is really unpolar, acetic acid is really polar, so they won't interact. Here it is different. You have the polar groups on the C18A phase and they will interact. So this is this hydrogen bonding capacity. And here you get a good retardation for acetic acid. And the second thing is acetic acid has to be dissolved in pure water. It is not soluble in organic solvents. So you have to inject it in pure water, and the mobile phase should also be pure water. And this can perfectly done with a C18A phase and not with a C18 phase, because here the chains of the phase would collapse because they are so unpolar, the water is so polar. So acetic acid, a really good usage for C18A phases. The C18H phase we saw before is really unpolar. So here also the analytes are some unpolar things. Like this molecule we see here, DNOP it's called, and you see it is not really polar, it has these long chains in the end with the unpolar rests, and this is a good example for a C18H phase. And the C18H can also be used in an extended pH range. It's also something really special because it is so stable. C18P is again something special, also pH stable, but it also has a really good steric selectivity because the chains are really standing in a row and can't collapse so easily. So you can also do something like these molecules. They are really similar, but because of the little steric differences, they can be separated on a C18P phase, what can never be done on a classic C18 phase. So this is an application that we have also done, and it worked really good on this polymeric bonding phase. There are also different reversed phase columns, as you might know, not only C18 phases, there are also C8 phases. They're just the chains are shorter, not 18 C atoms in a row, but 8. There are also C8A phases, what is the same as a C18A, but with the C8 chains. There are C4 columns, so again a shorter chain, and there are phenyl columns, something really special with these groups and the end. When is now a C8 column used? So here typically something like aminophenol can be analyzed. This works really well. On a C18A phase, something a little bit more polar can be analyzed. So again, we are getting more polar than in the C8 range, and again we can use pure water as a mobile phase, and it is needed here for the acesulfam K analysis. C4 columns are typically used for small peptides. If you want to analyze bigger peptides, please have a look at our white pore silica gel materials. There is a separate video on them. And these phases can perfectly be used when you have these aromatic rings also in your analytes. Here maybe you can also use a C18 phase for the analysis, but here these two molecules are so similar, but the separation worked really well on this phenyl phase because the aromatic interactions are really good. So now if we are comparing the reversed phase selectivity, we talked about polar retention and also about hydrophobic retention. So these interactions are making the most of your retardation. Also the steric interaction, but these both here are more important in general. So when you compare them, you can do some tests to get them, and we did it for our columns using Tanaka tests. And then you get this chart where you can have a description and see where your columns lie. And you see we can offer a really broad range of selectivity with our Eurosphere 2 columns. So in nearly any case, you can use one of these columns from this column family to solve your application problem. But as you might know, KNAUER also offers different column brands. So to fill the gap here in between, we also have columns from different manufacturers that we fill in our hardware here in-house, and so we can offer a solution for nearly anything. Now we talked about reversed phase columns, but let's also have a short look at the normal phase columns. In normal phase mode, you typically use bare silica gel phases or diol phases, or also amino phases or cyano phases. So this is something typical because in normal phase you use really hydrophobic eluents, and your molecules interact with these polar phases. So it's really the other way around than in a reversed phase mode. And there are also helic columns, and you see here you use nearly the same columns. So helic mode is really done on the same columns as normal phase, but with a completely different eluent, because you use here the hydrophilic interactions of the analytes with the phase and with an aqueous layer on your phase. So these columns, same stationary phase, completely different mode in helic. And there's also a special phase we also offer at zwitterionic phase in the helic mode. Now we are at an end for this overview about our HPLC columns for the analysis of small molecules. And you're invited, if you want to learn more about HPLC columns, click our websites on knauer.net for more information about columns. Watch our other KNAUER Academy videos to get an insight into many topics, and if you don't find the answer to your question, please write us an email to columns@knauer.net.